Good morning, good afternoon, good evening. Welcome back to the TSTSI Tech Deep Dive Conference. We will now have the session on the conference theme, which is Building a Sustainable Future with 6G in India. This session is being co-chaired by Professor Bhaskar Ramamurthy, past chair of TSTSI, and Mr. Suresh Chitturi, current vice chairman of TSTSI. I would like to introduce the co-chairs. Can we have the slides, please? So, may I introduce Professor Bhaskar Ramamurthy and invite him to the dais? Next. Professor Bhaskar was instrumental in the setting up of India's own telecom STO, TSTSI, about a decade ago. During his term as chair, Professor Bhaskar grew TSTSI from a startup to a vibrant STO, making its mark on the global stage. He also mentored key technical contributions, especially to 5G-I, that came from IITs and the CEBIT. Thank you, Professor Bhaskar, for joining us. I'd like to now introduce Suresh Chitturi, our current vice chair at TSTSI. Suresh is currently the senior director and head of technology standards at Samsung Research, Bangalore, and serves as a TSTSI vice chair. He's serving as a TSTSI vice chair since 2022. He has over 20 years of experience in the mobile technology industry and is responsible for research and standardization of emerging wireless and IoT technologies in global and regional standardization bodies such as 3GPP, ITU, FIRA, and TSTSI. Welcome, Suresh. We'd like to start the session with a keynote by Professor Bhaskar Ramamurthy for this session. Over to you, sir.
So, very good afternoon to everybody here. So, what I've done is prepared a few slides, very small number, to set the context on this whole discussion about sustainability of the communication technology, wireless tech, the cellular technology that we're all using now non-stop. How does it change? Yeah, next slide, please. I've already. Can you please change the slide? Okay. Okay, no problem. So, what I'm going to just set the context, what has happened in let's say mobile broadband. It started off as a voice communication system, but it slowly, by the time you went to 3G, it was moving towards becoming a broadband system. So I just called it a mobile broadband system. There's been scorching growth. So first of all, we have connected in the Indian context. It has not just been growth in providing some new capabilities for people who had something earlier, like in the West, where they had a telephone. Now they have some mobile telephone, and then they have mobile broadband. Here it actually connected the unconnected. Most people in the country, the first phone they ever had was a mobile phone. And even now the only phone they have is a mobile phone. And the first broadband connection they have is a mobile broadband connection. Okay? And numbers you can, and it's not, I just took it off the top of my head. Some 800 million broadband connections in India, despite the very low per capita GDP. I don't think, if you just compare countries with the same per capita GDP and see where they stand, it will be very, very small as a percentage of the population. Also very affordable. So when a country with such low per capita GDP, so many people have a mobile broadband connection, it must be affordable, right? But at the same time, despite achieving all this, the broadband speeds have really gone up, right? Started out at tens of kilobits per second with Edge, and even with 3G, maybe sometimes you get 100 kilobits per second. Now it's in tens and hundreds of megabit per second, right? The energy consumption on the network side, not something visible to everybody. If you look at the numbers, it's been roughly steady. in terms of order of magnitude. In the early years, when it was 2G and 3G, a lot of the energy just went in air conditioning. You had diesel generators and just to air condition the shelter so that the equipment would work reliably. That RF equipment itself didn't consume as much energy as it does today. What has happened now is the total power consumption is probably in the same ballpark. There's no air conditioning in the tower now. At least most of the equipment is on top of the tower. But it does consume much more power than earlier, simply because it's radiating in a wider bandwidth, and the kind of system you're using, there's a lot of energy going as heat. We'll talk about that. This is not working. Somebody has to change the slide. Okay. So if you want to reduce the RF power consumption, I'm only approaching this from a fundamental principles angle. What can you do? Today what's happening is you are sending out the RF power in a sector in all directions because you pretty much don't know where the user is, and you thereby reach the users. It's like I want to talk to Bindu alone, but I just shout in this whole room, she'll also hear it. Okay? Well, one thing you can do is you radiate power only towards these users to whom you are wanting to send the information. Don't send it everywhere. That should somewhere result in less energy consumption. This is what is called beamforming, right? However, some of the speed improvement, some of these fantastic broadband speeds that we are all enjoying today is coming from something called MIMO. And MIMO is a sort of goes in the opposite direction. What MIMO does is sends energy in a lot of directions, and you are hoping that what you transmit will reach the user from multiple directions, and that multiple copies enable you to transmit more data. Okay? So MIMO wants you to transmit in all directions or many directions, whereas beamforming wants you to transmit towards the user. So basically, the one challenge in 6G, if you want to really look at sustainability, is to create a win-win situation despite these two counteracting demands. Okay? So I'll leave it at that. I'm not getting into how, what. Next. The other thing that has happened since 4G is that we have moved to some technique called OFDM. Doesn't matter if you don't know what it is or if you know what it is. What this allows you to do is, as you transmit on wider bandwidths, 3G we were doing it in 5 or 10 megahertz, and now you're doing it in 100 megahertz. Channel's behavior changes a lot across that band, and you have to mold your transmitted data, put more bits where the signal is good, the frequencies in the band where the signal is good, put less, and this changes with time. You have to do this in real time, and you can do this very well with OFDM, and that's really why OFDM has become the method of choice in 4G and 5G. However, it turns out that with OFDM, the power amplifier, which finally, the equivalent of this mic amplifier, has to back off a lot. If it has to make sure that it doesn't destroy the OFDM signal. Back off means to transmit 1 watt, I have to operate the amplifier consuming about 8 to 10, 9 watts. The rest of it will just go as heat. It's basically a nice cooking stove, okay, sitting up there. So a lot of energy is going waste in trying to maintain this pristineness of this OFDM waveform. And why are you using OFDM? Because it allows you to really pump as much data as you can through this time varying channel. On the other hand, if you didn't do multi-frequency communication, orthogonal frequency division multiplexing, if you did single carrier modulation, it turns out you don't have to back off the PA so much, or may not have to back off at all if you looked at what happened at GSM. So again, there are pulls in opposite directions. So one of the second challenge in 6G is what do we do to maybe get a mix of these two or something which will waste less power, less energy as heat at the tower top, and thereby achieve better energy efficiency. Next slide, please. The third major thing is what I call embedded. This is a very common, very well-known concept in a lot of engineering, particularly very popular in civil engineering and so on, because cement looks very harmless, but making cement consumes a lot of energy. So if you make cement and you build a building, the longer you use the building, the more sustainable it is. So they have a notion of what's called embedded energy, how much energy is embedded in that. And after that, when you destroy, you can't reuse cement. So the building is broken up. Same way electronics, you can't reuse electronics, right? You throw away the electronics, it gets, you can extract some gold and all that from that. But similar, there's not much you can do with this. You have to, the next set of electronics is new. So it has some similarity to that. So there's a notion of how much energy went into making all the electronics and all the aluminum and everything that goes into the base station, right? That would be the embedded energy. Obviously, the longer you use it, the embedded energy per life year of that equipment, the better it is. Okay. So now, on the other hand, why do we change things? Why do we go from 4G to 5G and 5G to 6G? Because in a 10-year time, typically when we change it, the compute capability of chips has improved a lot. Our ability to transmit at higher frequencies has improved a lot, and so on. So we go into new spectrum, we want more, we come up with new algorithms that use a lot of compute, we use AI, we do all kinds of things to achieve better performance. You can't implement all those on the old chips. So you have to change everything, right? So there is today, every 10 years, we are pulling out everything and adding stuff. The old stuff stays a little longer, finally it's pulled out, and so on. So there is a certain embedded energy per life year. How do we improve this? Can standards be developed in such a way that, we always, in standards, a lot of energy and effort of the human beings goes in ensuring backward compatibility. Not a single thing can be incompatible backwards, every bit, every signal. Why can't similar efforts be put into maximizing the reuse of older components? Okay, instead of just not even thinking about it. Okay, that could be a constraint in standardization, right? So these are all ways to think about that. So that's the third challenge. Okay, on the phone side also it is there, by the way. In fact, this problem is very severe on the phone side. Okay, the way things are right now, people are being, I would say, made to replace phones every 3 years. And that number is well established. Even poor Indians are buying 16 crore smartphones a year, which means we are buying in 3 years 48 crore, 50 crore smartphones. We have only 30 crore families. So every family is, on average, is buying 2 smartphones, 1.8 smartphones every 3 years, right? It's very high. In fact, we are spending as much on that as we are spending on two-wheelers, for example, right? A two-wheeler lasts for 8 years. Just to understand this idea of embedded energy and what it is, right? So pretty bad. Things are very bad on the phone side. And that's also happening partly because of the same thing. If you want the phones to do all these fancy things, new things, then you need a new computer in it, a new processor in it, and so on. But partly it is also business driven. I think that also needs to be, I don't want to talk more about it here, but some countries have already started legislating about this, right? About making sure that what you sell can work for 7 years and so on. At least make sure the software doesn't make it disabled. Okay, so there are some regulations coming up in Europe and so on, but people are becoming aware of this issue. Next slide, please. I think that's it. Please show the next slide. Yeah. So if you look at the whole sustainability issue, there is a huge aspect of sustainability having to do with the amount of energy you're consuming at the place where all your bit traffic is going, which is data centers. So you are searching for something, you are going to some, maps or whatever, everything is going to data centers and coming from data centers. Data centers are big guzzlers, but that I think better to think of it separately, because whether you connect through the mobile system or whether you connect through a land fiber optic system is immaterial. I don't think we should confuse the sustainability issue in connectivity by bringing in that also into the picture. Though you often, the same company might be running both, that doesn't matter. So I would say we should restrict out, people should look at data centers, but that's a separate problem. We should look at how we can make the connectivity system. Compared to the wireless mobile system, optical systems and all consume very little energy. So focus on the mobile system and see how to make it much more sustainable in 6G. But just to leave one number with all of you, the 5G system today, ballpark figure, it consumes about a kilowatt per sector. So 3 kilowatts, maybe 4 in a site. Typically, a sector serves about 250, 300 users at a time. So it's about 1,000 users being served by 3 kilowatts. Per user, it's about, right, 3 watts, 4 watts or something. It's still less than the light bulb in your room. So one should not get too excited about all this, but it is important. But there are many other things in which we are guzzling power much more than in communications. Thank you.
Thank you very much, Professor Bhaskar, for setting the context and also touching upon some topics which affect us in a daily manner, like replacing the need to replace phones. And you alluded to something which is being considered as circular economy. I think we will be covering that in the panel discussion a little bit more in detail. We will now proceed to the keynotes of this session. We'd like to invite Ms. Susanna Kallio from Nokia to deliver her keynote. May I request her introduction to be please brought up on the slide? Ms. Kallio, I hope you are there online and you will be able to make your presentation. IT team to confirm. Yes, thank you. So, Ms. Susanna Kallio is the Head of Sustainability Standardization in Nokia. She has a master's degree in electronics engineering. And over to you, Ms. Kallio, for your presentation.
Thank you. So I will share my presentation from here. And thank you for the invitation for this conference. So I've been listening in all the presentations when I have had time, so connecting, and very, very important topics and very good discussion here. So I will then talk about the sustainability, which is on the outer circle of this picture. Very wise words from Professor Bhaskar, so I will build on that. We need to look at holistic environmental impact. So climate change is one topic which have been discussed quite much, and people start to be very familiar about that. Organizations and companies are already reporting their company footprint, company greenhouse gas emissions, and also their product embodied and greenhouse gas emissions involved with the product use. So that area is quite much standardized, how to assess the emissions and the environmental impacts from that. But in addition, we need to consider geodiversity loss and biodiversity loss. Geodiversity here meaning the non-living nature aspects in the nature, like rocks, minerals, water. And then biodiversity meaning the living aspects of the nature, like animals and plants. So for geodiversity, we are then taking the materials out of the earth when we produce our products and networks. And that is then something where the main mitigation is circularity. As already mentioned today, so we need to try to keep the products in use as long as possible. Of course, not sacrificing safety or product functionality or the durability of the products, but still trying to keep the loop closed so that it would be circulating either on material level or then these components parts level, or then in the material level, recycling the material from the products. On biodiversity, so we are just now standardizing the methodology how to assess biodiversity impact from ICT. So the work is ongoing in ITUT, and there we try to then create the methodology so that we can see what is then the impact from ICT on biodiversity. Biodiversity loss is very much linked with changes in land use and sea use, when we take material out of the globe or out of the earth. So that, of course, impacts the mines, impact the land use. And also when we then build and install networks, that has also impact on land use. And also when we use energy, so renewable energy, for example, so wind farms, solar farms, they have an impact on land use and sea use. climate change is very much linked to biodiversity. So when the temperature rises, that impacts the species, and some species don't tolerate the higher temperatures, so they will extinct. But then there are other species which like it when it's getting warmer, and they will then expand and really like grow a lot, and they take then space from other species. So that is then also linked with the biodiversity impacts. It has been said that a major portion of the product environmental impact is determined in the use or it's determined in the design phase of the product or network equipment. So it has been said that even 80% of the impact comes from the design. And that is the good news, because now we are in the design phase of 6G. So there we can then now influence, when keeping in mind always the environmental impact, that we need to look at that and then try to bring such 6G design that the environmental impact has been taken care of. Looking at energy efficiency, Professor Bhaskar already gave very good examples what actions could be taken for reducing energy consumption. So as we have heard many times this week, 6G, when it's becoming more capacity and then also, of course, more computing power in 6G, so that inevitably then increases the energy consumption. So that is where we have the challenge that we need to keep the energy consumption on some reasonable level. Already mentioned that the cooling of the higher computation power, so that needs to be solved somehow so that there will not be excessive impacts to the environment. We are already today using AI for network management and also in energy saving, and also then like increasing energy efficiency. So that is very good. We can utilize AI for these purposes, but also then there's the other side of the AI, that it consumes a lot of energy. So there as well, we need to balance between these two sides of the technology. Circularity then, so as mentioned, so here we try to keep the product on the highest utility level, and so this is already practices today. And so when the product finishes or comes to the end of use at the current site or current customer, so we take back the product to then check whether it's still refurbishable and whether it can be put back to the use, to the second or next life of use of the product. And when it's not anymore possible, so then taking then components and parts for spare parts for other products if possible, or then if none of this is possible, so then at least recycling the material so that then we can bring the material into some other product. So the target here should be, of course, 100% circular, so that we don't take any new material from the ground anymore. That is quite optimistic target and difficult to reach, but also keeping this in mind when we are doing 6G design, that we should extend the operating lifetime of the network and also then increase the recycling and reuse refurbishment of the products, and then increasing reused components and recycled content in the production of the equipment. So all of this then brings sustainable 6G. So it impacts the footprint, the negative impact what 6G will have. So we need to minimize the negative impact. So there already mentioned improving energy efficiency and also with circularity reducing waste, and also then not taking new material from the ground. But also then we have the other aspect. We have now the opportunity for 6G for sustainability, for the handprint part. So maximizing the positive impact that we can make with 6G. So that means then enabling other sectors and society to decrease their environmental impact while using 6G networks or ICT in general. So also there is now a green transition ongoing. So they're now investigating new use cases, how 6G can be then utilized for improving and benefiting the green transition. And also then on social aspect, so connecting the unconnected with 6G. I come to the conclusion. So key takeaways, holistic environmental impact, we need to consider, in addition to climate change, also the biodiversity loss and geodiversity loss, so the holistic environmental impact. Standards are very much needed so that industry will agree on the sustainable 6G, on the footprint part, so minimizing the negative impact from 6G, keeping always in mind when designing new features or functionality or the network or the architecture. So keeping in mind, keeping it lean, and also then remembering sufficiency. So what is enough, and not over planning then, and not kind of using too much resources and creating too much environmental impact. And then, of course, we have now the opportunity for the handprint part. So 6G then enabling other sectors to reduce their environmental impact. Thank you.
Thank you very much, Ms. Kallio, for your keynote. I especially have noted the fact, what you mentioned, that 80% of impact comes from the design phase. And since we are in the design phase for 6G, there is hope for us. Thank you very much, Ms. Kallio, again. We now move to the next keynote from Mr. Eric Gutman. Can we have his introduction, please? So Eric is currently representing Samsung in the 3GPP SA1 services and 3GPP SA5 telecom management working groups. He has previously served as a chair of the Services and System Aspects Technical Standards Group of the 3GPP organization from 2015 to 2019. This group is responsible for management of activity within the Services and System Aspects working groups, as well as coordination between 3GPP groups and other standards organizations. Prior to this, he served as a chair of the 3GPP SA2 Architecture Working Group, which is responsible for the overall 3GPP system technical specifications. Eric also served as the IETF SVR LOC and Zero Config Work Group chair and contributed actively to the IETF standards in the internet area. Over to you, Eric, for your keynote.
Hi, so hopefully I'm sharing my presentation. I don't know if it, let me know if it isn't there. So I'm going to go in a slightly different direction. To approach 6G, I want to talk about what we're doing now. And we can see the direction. Typically at the end of a generation, you can see the direction. Is the presentation being shared? Maybe I'll try again. Aha, okay, that's much better. So looking at 3GPP from a distance, you can see that it has this range of generations. And GSM sort of prefigured it and established the basis. And so when we talk about the technology and the issues that we have, largely they come all the way from the origins of 3GPP. And we've done tremendous work since, and we're building, however, on this basis. And I don't even have 6G on this chart because we're in the process of doing work. And so I'm going to sort of show you where we are, and you can see that 6G is coming, but where are we now? We're finishing something called release 18, and we're starting something called release 19. 6G will kind of fit in release 20, 21. We're still debating exactly when and how. The reason why this is important is that we're already starting to address energy issues in the sort of tail part of 5G. And this is almost always the case with 3GP. We begin to address the issues that are leading in the next generation at the end of the current one. So I'm going to talk about 3 topics that are exciting and concern the overall progress in 3GP today. And I'll make some reference to these release 18 and 19. You can kind of keep this overall picture in mind. I'm not going to talk about the detail. This is a program management slide. So the first topic is really the most important. And this is, I say, goes from release 15 onwards. That's for 5G. But in fact, many of these programs go all the way back to the earliest phases. They were even considered to some extent in GSM. There's this concept of energy efficiency. And let's be very clear what that means. We look at the actual performance and we divide it by the consumption. And the performance is a metric like number of bits transmitted. And the energy consumption is like in some sort of milliwatt hours or some unit of energy. And you can compare the work that's being done in one network to provide that quantum of work to another network. And you say, okay, this network is performing that quantum of work with less energy than that one. So it is more efficient. That's what we mean by energy efficiency, really. And this is sort of a very general term that is applied to telecommunications, but it could be applied to anything. Energy savings is an entirely different matter, and that's something that we're taking seriously now. And energy savings is an intervention in the system to allow it to operate, but using less energy. Now, we had sort of an excellent talk to initiate this session from Professor Ramamurthy, where he noted that even though we're doing much more, we're not actually, in the end, when you look at the net energy, saving that much. Now, what that means, however, is that we've done a tremendous amount to save energy. It's just we try and do more and more and more. And again, there's this trade-off. Like, at what point do we say that we actually want to use less energy? And what will the consequences of that be? And one of the things we decided in 3GP was we're not going to trade off performance for energy savings. That sounds kind of strange, right? Because how else are you going to do this trade-off? But the end of the story is you're not going to trade off performance that you've guaranteed. So we have to be very careful what we promise. And that's going to be a theme as we go forward in my talk here. So what are we actually doing now? We're collecting a lot of information in order to identify what this efficiency is. And we're providing more and more mechanisms to control the network so that we can actually save energy. How do you do that? Well, maybe you can turn off certain parts of your infrastructure when you don't need it late at night or something. Now, it's very important to sort of add on to the initial talk, which is about the RAN and the energy cost, with the actual footprint that we're experiencing, which is highly related to the data centers. And data center growth and the whole data center support of this is very energy intensive, and it just continues to grow and grow. Now, standards are only going to be able to do so much there, but this is an important theme, okay? So we have this automation orchestration framework that was standardized in ETSI that we are leveraging. So that's this NFV concept. What we do in 3GP is we define mechanisms that terminate those orchestration functions to allow us to do things to collect the data that we need and to automate the mechanisms that are available in order to control this energy use. This is quite a dynamic topic, and we continue to add more and more functionality, both at the RAN level and at the network level. And a key component of this is the ability to actually monitor energy utilization and expose it so that you can do capacity planning and so that you can actually determine when and where you can do these reductions in utilization, which is both a real-time task and much more a sort of capacity planning task, which takes time in weeks, months, years, whatever. Okay, so I want to talk about another project in 3GP where what we're doing is we're looking at how energy utilities and communication sort of mobile network operators have a lot of common interest. And the main common interest they have, oh, wait a minute, that's my next slide. I have the, right. I have, right, this is correct. Okay, I'm sorry, I confused myself here. This is correct. So one of the issues we have is availability. Why is availability such a critical shared concern? Well, in order to operate a mobile network at all, you need energy. And now, in order to operate a utility network, you need communications. And so we basically have a vicious circle. If one of these two is not in operation, the other two will fail, or the other will fail. And so there's what we call a kind of fate sharing. So what do we do in order to keep the communication system highly available for the utilities? When we talk about availability, we talk about numbers of nines. And in fact, if you look at the achieved availability in the overall network, it is not 6 nines. Okay, it's definitely not 7 nines or 8 nines. And the problem is once the utility network goes down, then the telecommunication system will go down for a lot longer. If you look at the statistics on what is the major cause of telecommunication outage, it's energy outage. Now, what we're going to do is, and what we're actually in the process of standardizing now, is exposure of performance information to the energy utility. The energy utility can then, if you see on the right, it's this performance over time, they can monitor this orange decline. And they can identify when they're approaching this KPI lower bound, in which case their system would fail to be able to do remote control and data acquisition and all the things they need to do. So what they do is a proactive failover to another network. This means you're actually leveraging multiple mobile networks at the same time. And when one begins to threaten to cease operation, proactively you switch to the other network. This takes time. You might ask yourself, why not just use them both at the same time? Well, that uses a lot of energy and it also is expensive and they don't do that. So that's one project. The other project, which I'll only mention briefly, is that if there's an energy outage, one of the problems is bringing the mobile network back online. Well, I'm sorry, bringing the energy network back online. You need the mobile network to do it. So the question is, how do you do that? You can actually coordinate this through standards where the mobile network operator is informed, hey, there's an outage coming, maybe a planned outage. And there could be actual planning in terms of how the recovery is done or how the uninterruptible power supply is managed to minimize or even eliminate the outage of the mobile system's secondary power supply. If you can maintain continual operation of the mobile network during the time you need to do these remote recovery operations, you can go from hours of outage down to a few seconds. And that is a tremendous savings in terms of availability if you want to achieve those larger number of nines. The last topic I want to describe is as a new concept, which is considering energy as a service criteria. So I just want to mention that the design of each of these mobile generations up to the present one is aiming at achieving a high level of performance for all users. Okay, this means that even best effort traffic is amplified to the point where you don't notice much of a degradation, even when you're in a very unfavorable position vis-a-vis the antennas. Now, of course, there are all kinds of mitigating technologies that were described in Professor Ramamurthy's talk, but all of these require a lot of energy. The further you are from the transmitter, the more energy they need. So what this proposal is that you can actually determine a cap for the energy, which will necessarily imply that you have a declining performance as you go to the network edge. This is not a proposal for all forms of traffic, but there are certain forms of traffic, an important classification of these, that are resilient to intermittent reduction in performance. And for these, you could actually reduce the energy expense for the communication in a measurable way that could have a significant effect. Other areas of interest are exposing to the third party how much energy they're using, making them pay for the energy they're using, identifying what kind of carbon emissions and carbon intensity or renewable energy use their services imply, right? So how are these being provided to the customer? And this may be interesting to the customer for a number of reasons. Possibly there are regulations that are identifying what their targets are and they can show that they're meeting them. So these were three, I would say, key examples of where 3GPP standardization is addressing areas of sustainability. Now, this is not going anywhere near the direction of the previous talk, which is excellent because we're covering it from different angles. But here we're basically showing that 3GP is already beginning to actively wrestle with these 6 key topics that you will see maturing and becoming more ambitious in the years, just very few years to come. So in the next 2 or 3 years, these will become the key themes of 6G, in my humble opinion. So thank you very much.
Thank you, Eric, for giving us some indication of the work happening in 3GPP from a sustainability energy aspects. We now move to the next part of this session, which is a panel discussion, which will be moderated by Suresh. We are joined by Mr. Vikram Tewatia and Mr. Avinash Agarwal for this panel, and Mr. Mombasawala for the panel, apart from Professor Bhaskar, Susanna, and Eric. May I invite the other panelists to please join us on the dais. I'd like to introduce them as they move to the dais. Can we have the introduction slides, please? Yeah. So Avinash is currently an ITS officer of the 1992 batch, and he is currently working with the Telecom Engineering Center. He's posted as a Deputy Director General, Convergence and Broadcasting at TEC in New Delhi. Thank you, Avinash, for joining us. Next, we have Mr. Mombasawala. Mr. Mombasawala is a Chief Technology Officer at Keysight Technologies, and he heads a team of industry segment experts in commercial communications, network security and testing, memory and peripherals, interconnects, as well as automotive and energy solutions. Mr. Mombasawala has 33 years of experience in various technology domains listed here. Thank you, Mr. Mombasawala. And last but not the least, Vikram from the operators segment. Can you please go back to Vikram's introduction? Everybody knows Vikram, I think, here, but it's my pleasant duty to introduce him again. He's a Deputy Director General at COAI, and everybody knows COAI. He represents the operator segment, and that's the segment that he'll be representing in the panel here. Over to you, Suresh, for taking this forward.
Thank you, Bindu, for opening the panel session. As you can see, we have quite a distinguished panel here and very diverse as well. Sitting here in person, but also remotely, Eric and Susanna join us here. Now, sustainability, is a very broad subject, but it's becoming very increasingly important. I say broad because it's not just connectivity, but it's climate change, being more efficient energy-wise, and so on. But I think we try to maybe stay a bit more focused on telecoms or digital communication, as in the previous session, Mr. Pathak was saying that we're no longer just telecoms, but digital communications. So just to give a bit more context, Professor Bhaskar, set some context at the beginning, but why sustainability is very important is because, starting from, I think you're probably familiar already with the UN Sustainable Development Goals from 2015, where I think affordable and clean energy is one of their sustainable goals. And I have some numbers here that suggest that energy actually contributes to 73% of climate change issues. So it's pretty significant. And then they also say energy efficiency can lead to 40% of emission cuts without introducing new technology. So which means if you're just able to optimize or be more energy efficient with the technology we use now, it can lead to up to 40% emission cuts. So that's quite significant, right? And then very recently in June this year, we have the IMT 2030 vision that also, talks about sustainability. If you have seen the wheel of, IMT 2030, sustainability is a big part of it. And it's not sort of a KPI as such, but I think it's been referred to as a design by principle. So whatever you do in IMT 2030 or 6G, I think sustainability needs to be taken as a design principle, just like security, right? We don't say, your network should be 100% secure or, 50% secure, but, it's you design it that it's secure. They do talk about circular economy. I think we can still touch on that. They also have a metric on energy efficiency, and I think Eric referred to it in 3GPP context. Like we have the spectrum efficiency, right, where we say, bits per hertz. Now we have a metric that says bits per joules. So that's kind of a metric that I think we'll start to use quite heavily going forward. And then we Professor Bhaskar also, referred to, data consumption kind of growing significantly. And, this actually may be the crux of it. We use a lot more than we actually need, perhaps. And obviously, when the data consumption, really goes high and, everything is connected to the telecom networks, then, obviously you're going to consume energy and then you make these trade-offs. So with this backdrop, I will open up the panel for discussion. So I would probably, like to ask that, you limit your responses to maybe 2 minutes per response. So we can kind of, have a chance to hear from everybody and cover as much ground as we can in the given amount of time. So let me start with my first question. Since I did mention about IMT 2030, there is sustainability is an overarching principle, in the whole kind of approach to IMT 2030, not just environmental, but also social sustainability. And when I say social sustainability, probably more specific to India is that we want the cost also to be lower in terms of deployment, right? Because that's a big part. So that's also one aspect of sustainability, and we probably get there by having more efficient deployments, maybe rural broadband or rural wireless and things like that. So my question is, will IMT 2030, based on what we have seen from the vision, achieve or meet the sustainable goals? And is there sufficient guidance available? Do we know what the requirements are? Because I think very soon, we're going to start the real work on 6G. So I think this is the right time to actually understand, is the vision actually, reflect what is the need of the hour, and do we have those requirements? So maybe I first go to Susanna. Do you want to respond to this?
Yes, thank you. Very good question. Yes, when looking this IMT 2030 framework and the sustainability goals there, so then they put then the target to reduce climate change impact, so reducing greenhouse gas emissions, and then also they mentioned their circularity. So very well covered. So that circularity should be implemented and also efficiently used. So in that sense, covering wide topics, but of course, it's very difficult to then set exact goals. So I would say that we should target for 100% circularity, and then we proceed, how far we get. And of course, we have then this net zero target set for 2050 in the different organizations. So for that, then of course 6G also plays a role. And in ITU-T, there's a standard L1470, which has put a trajectory for this net zero. So how to reach that, and then what that would then mean in 2030. So in 2030, it means 50% reduction from year 2015 in ICT sector. So of course, that's also then a challenging target since we already have established a baseline or so installed baseline out there in the field. So it might be difficult for them to reduce their emissions. So therefore, 6G needs to take a larger share of that 50%. But so I think all in all, it's very good that we have these targets, and we need to be working towards those. It's very difficult to quantify in values, in numbers, but so I think always we need to target for the very best. So net zero and 100% recyclability.
Okay, thank you, Susanna. I think you sound very optimistic, so that's good. I think we all need to be optimistic. So then I the same question to Vikram.
Thank you, Suresh. So, I would see this more as 6G for sustainability, because the various SDGs are listed out, the 15, 16, 17. So each one is specific. Now, the good part is that I would not really call it 6G, but digitization will be the underlying catalyst to enable the achievement of these SDGs. Whether it's to improve the logistics, improve the agriculture, reduce greenhouse gas. So the good news is that the digital communication services sector, by facilitating the growth of sensors, IoT, M2M, various types of communications that we've got, will be a significant catalyst, as I said earlier, to enable achieving these SDGs. And of course, sustainable 6G, that is an internal role, how to make 6G itself more energy efficient. Obviously, that is something which Professor Bhaskar mentioned and others have mentioned.
It's reasonable. Yeah, I think as much as we want to have a sustainable 6G, I think how 6G can actually make a sustainable world is, I think, also very important. And then, Mr. Avinash, would you like to respond to the same question?
Thank you. So, I think when we are talking of 6G or IMT 2030, so the framework is just being finalized at ITUR, and sustainability is already one of the capabilities. And even if we talk for India, then even the Bharat 6G vision also has lots of emphasis on sustainability. So the focus is right, it's there. And perhaps the next stage will be the framing of the requirements at ITUR. So as we move forward, the requirements will also be there. Perhaps they are not available right now, but they will be there. And maybe there are 2-3 aspects. One is that sustainability, when we are talking of environmental sustainability, and then sometimes it's energy efficiency and other things. So as Professor Ramamurthy mentioned, something is technology driven also. If we are talking of beam forming and other things, sometimes it might be a basic mandatory requirement, because if we are talking of certain devices which are very small devices remotely located, which cannot even be charged during their lifetime. So again, energy efficiency might be a requirement itself. So of course, right now the focus is there, but perhaps as we move forward, the requirements would also be there. Thank you.
Yeah. Thank you, Mr. Avinash. Professor Bhaskar, would you like to add to this discussion on, whether IMT 2030 has sufficient vision in place in terms of what we need to achieve, or anything specific that you think people need to think beyond what's out there?
We have to be, I think we've not, we just as Eric was also pointing out, the focus on, we started looking at the energy axis last few years, but I don't think any standard has been ab initio developed with this as one of the main focus areas. Maybe 6G is an opportunity, but we have to be a little careful, I think, in focusing on those things where we have a choice when we standardize on how to do things, how to do more with less, and not look at the bigger, because the bigger problem is many other variables and many other decisions, many other policies. As I said, data centers, whether how much AI do you use, how much energy do you spend on an AI algorithm for what, how do you price it? All those are not, we can't get into all that. I think the only thing is, it's just like saying if you want to design a car, you can design a car as well as you can. How much somebody drives it is not in this scope, right? So we should be very careful. I think there's quite a bit to do. I tried to allude to a few things, quite a bit to do in the standard itself, where we can actually, I think, by focusing on how much energy we consume, the three challenges I pointed out, I'm sure there are more, where we can make our choices based on using a more efficient path than less. But that's how we have to remain focused. It's very easy to get sidetracked. Looking at a very big problem, where we don't have all the, we're not the people deciding all the things. Right.
Thank you. That's very good advice. And I think, yeah, if you start to look at the very big picture, then always there is a bit of. Actually, it's a good segue to what I was going to trigger with my next question. But Vikram, you want to?
Personally, if I had a choice, I know I don't, but here's a suggestion. We have these 17 SDGs. I think there is a good case to add one more SDG is getting rid of digital trash. The amount of trash, you see all the surveillance cameras, all the photographs in your device, you're producing a lot of content. Then you're spending energy saving that content, keeping it, in the data centers which process it. And, this is a question I'd ask for your person who started the internet. How do we get rid of digital trash? Because, yes, you want to do education, you want to do health, as part of these SDGs. But in doing so, and the pike, like we are going 5G, 6G, and, more data is being pushed up. So, point for consideration.
Good point. Interesting perspective. I did not cover or plan for this aspect, but I think it's a very interesting perspective. So just on the just to where Professor Bhaskar left us with, yeah, I think there's a little bit of this is more around being a little devil's advocate, right? So obviously, once you start enforcing energy efficiency or energy savings. So what you may effectively do is actually have an impact on performance or quality of service, right? So then one would question, are we doing the right thing? Because on one hand, you have all these needs and consumption requirements. I mean, you like to call it digital trash, but I mean, people would like to do all different sort of things. And on the other hand, we want to conserve energy. So they're kind of contradicting requirements, right? And then similarly, this thing came up about data, data centers or virtualization. Because now the new thing in telecom is virtualization at the RAN, core, everything goes to data centers. Because we do this because we want more architecture flexibility, right? But by requiring more architecture flexibility, then you end up building data centers that consume. I don't know, Mamba, you're saying that 20% of all energy consumed is by data centers these days. That will be by the end of this decade, right? So you have all these conflicting requirements. So I mean, one could say, we're just moving problem from one end to the other end. We're shifting the problem. So what are what do we need to achieve this end to end? I mean, do we look at, Professor Bhaskar is like, okay, look at only things where we have control over. Let's not look at the big picture. But then even within our telecom or connectivity world, you still have these problems where, you tend to kind of have this need to make these trade-offs. So I would like the panel to kind of discuss this aspect and maybe start with Mamba on this.
So my response will be very technical. So bear with me. I'll speak about 6G technology in all the discussions that we are having with our customers. 6G cannot be viewed about a technology of mobility and coverage. Okay, there are verticals like holography, XR, automation, warehousing, where it will play a major role. If you look into 6G, there are two components of frequency, the 7 to 24 gigahertz band and the sub-terahertz band. Now, since we are operating at 5G now at 3.5 gigahertz kind of, if we are moving to the higher frequency, and the most interested band in the world right now is 12.5 to 13.5. That's the range. So if I see the ratio, it's around 4 times. And I'll need maybe 12 dB more power to cover the same distance, okay, because the loss is that high. So what's changing? I mean, a lot of power is needed if I model my network the same way. That's the first point. So I will have to redesign the whole thing from the energy efficiency point of view. Second thing is we are looking at MIMO and higher bandwidth at 6G for better data capabilities. If you increase bandwidth, the noise floor increases, you again have to increase the power. If you look at MIMO, even if you look at 4-layer MIMO today, they are energy guzzler. But what worries me the most, which I want to echo and resonate with Vikram, is the garbage that we have at the data center. Okay, today data center consumes 3% energy. By the end of the decade, they'll consume 20% of the energy, because we'll not be able to clean up the garbage. And at the same time, most of the applications are getting processed there. So whether it's a mix of edge computing or the cloud computing that we have, too much of computing will be needed with the AI algorithms that we'll deploy. So they will consume too much of energy. If I see an end-to-end holistic point of view, user connected to the content straight away, there are sections where enough energy will be consumed, and we'll have to audit each part and figure out right at the design stage, how do we reduce the energy? That's my take on this.
Thank you, Mohammed. It's very insightful. Susanna, would you want to respond to this question?
Oh, yes, please. So yeah, I also want to pick this digital trash. That was a really good comment, and so yeah, that starts to be really a problem. So we are not putting so much things on paper anymore. We are not cutting trees, but then we are storing data. So maybe people don't understand that also is kind of consuming energy, the storage, and so that's also then a problem. It would be great to get the solution for that. So that's one point. And so yes, what you mentioned earlier about the data centers and the computing power, what will be needed for all the nice fancy features that we want to have. So that starts to be a problem as well. And also then the cooling, so that consumes a lot of energy. So in that sense, we need to get to the point that we really can cut down energy consumption. And so it was very nice to hear from Eric that 3GPP is already on that path. So that's very good to hear.
Good, thank you. And Eric, do you have anything to add to this?
Yeah, I'd like to say that through the development of the internet, from the perspective of a consumer, there are ever more services. They're very important for operating your business and your personal affairs. They're important for running governments, for first responders. It's an incredibly important part of our society today. But the way the cost of energy, the cost of generating the energy, of delivering the energy, of using the energy is sort of distributed amongst us is opaque. That today, most people think it's free. You know, the data set, I just have these services. If the business model changes so that the service providers actually are restricted in their energy use or have to pay for their energy use, that they don't get a free ride, then the services will be designed in a different way because their business models will be impacted. And it's very important to see that this entire ecosystem affects all of the not only the sustainability goals, but also the sort of viability. We heard that for people with limited income, the use of these services, even though they're only paying indirectly through their subscription fees, is a huge part of their income. What if we basically look at this as a the reality of this cost? And once we do that, we know that there's sober engineering principles that we've abandoned because it's so easy to use big data. It's so easy to use these huge frameworks. We could do many of the things that we do today in terms of communication in the past using a tiny fraction. It's just a lot more work, and you have to reduce your expectations. So anyway, my view here is that by looking at an evolution of the business model, we'll see that the service providers have an incentive to have less digital trash and lower footprints in the data centers. And that also includes the mobile network operators, by the way.
Very interesting, Eric. Thank you. Yeah, I think, I mean, we're used to free service, free data maybe in India. So almost free maybe. Okay. Yeah, so I think that's a very interesting perspective because there is no incentive to actually conserve or reduce energy, and maybe if there are some business models or maybe that's maybe the next question to Vikram is how do you respond to Eric's view on creating that kind of, I think Eric maybe in his work he talked about energy as a service. So being able to measure and apply credits to the consumption of energy within a service. I mean, is that something the operator community would?
Suresh, thanks a ton. This takes me back to on one of my trips to Tokyo. Staying in the hotel, you could not increase the temperature or decrease the temperature of the air conditioning below 25. You could not increase the temperature of the geyser above some specified limit. And you actually, if you didn't put your clothes out, the towel or whatever, right, you actually got a reduction in your hotel bill. So there's a similar case in Switzerland, how you handle your trash and otherwise. But the fact of the matter is, yes, in telecom, as part of policy or regulation, if we are serious as countries to try and achieve, it has to be a mix of incentive and regulatory. So the business incentives, particularly for operators, the amount of OPEX on energy consumption for networks is really very high. So all CEOs, they have a very sharp eye on the amount of energy being consumed. So, and with every review, you want to cut down that energy level. Now, one of the challenges for us in India is we are not just telecom service providers, we are also power generators, electricity power generators. You see at every tower, you have to have a DG set because of the lack of, credibility of grid supply. So that's a particularly India problem, right? But there is a huge incentive amongst the operators to reduce the energy cost because it's a huge payout. And of course, if one can look at from a government point of view, how do you incentivize it? If I'm more energy efficient, can I get a reduction in my levies? So that, I'm incentivized to being more energy efficient.
Not just TSPs, but also maybe the user.
Whoever, if there is a national policy, because this is not just about telecom, but it is about, like I said, 6G for sustainability. That part, because digital services are facilitating agriculture or, education and others. So if they are also, doing it in a energy efficient way, that would, and they get some benefit out of that, I think that would be a good pike to go down.
Good. Thanks, Vikram. So then we just maybe going back to a little bit more technical discussion is on the, in the past we had, one way to be more efficient or, serve new use cases, we kind of increase the capacity in a way, right? So we've been kind of increasing the capabilities of the networks and, all these new technologies like MIMO and beamforming and we don't know what else would come, massive MIMO or X MIMO and things like that in the future, right? So, but what I see analogy is, we cannot just keep on adding new technologies just or increasing capacity, but we need to kind of look at it from in a more constrained environment, right? Like if you take an example of spectrum, so from 4G to 5G and 6G, you're going to sort of, you just cannot get more and more spectrum. You're going to be, at some point, you're limited with how much spectrum you have, even though you reform and things like that. So you need to start to think about, because it's not going to be there's not going to be a way to actually conserve energy if you start doing that. So now with that as context, I want to know, like, I think Professor Bhaskar, did mention about a few things, in sort of, do you do beamforming or do you do MIMO? What is the trade-off? How do you actually, work at the technology level to optimize and conserve energy? So maybe, Mamba, you have any thoughts from a research perspective or what you're doing at Keysight to address some of these challenges?
Okay, so there are various possibilities for sure in terms of how do we optimize, as Professor Bhaskar said, that you have the trade-off. Now, what our suggestion is, first you have to extract a lot of information about the operations of the network. That's what most of our customers are asking us. Okay. At Keysight, we have devised a mechanism wherein we put the software agent or the power amplifier in physical form, start collecting the power information, and then that is used in conjunction with the available processes in the network and try to figure out which are redundant processes that can be switched off to reduce the power consumption. Now that's getting little technical, but we will have to get that data and do the benchmarking of the network first. And then after we'll be able to figure out what are those points of optimization. So, whether you want to turn off the service this way or the other way will be decided both from the service rendering perspective as well as the energy consumption point of view. That matrix is yet to evolve. That's the domain of the operators and lot of designers and network equipment manufacturer, how they are going to do that. And this will evolve with time, and similar things will happen in the data centers and the other domains as well. So I feel with more data collection and benchmarking of networks, we'll be able to figure out what we can really optimize on and how do we achieve it. Yeah.
Very good. Then Eric, do you have a perspective on maybe from a 3GPP standards perspective? Where we go from here? I mean, you talked about the energy saving and efficiency in from an orchestration point of view, and then energy as a service. How do you see this kind of transitioning going into 6G?
So I concur with the previous speaker. One of the key issues we don't know, right, especially as the networks become more and more complex and we're dealing with virtualization and distributed services, the ability to control the infrastructure to reduce the overall expense of operations requires a lot of data. I mean, we have to be cognizant also of a principle called digital sobriety, where if we are monitoring too much, we're actually using more energy perhaps than the services themselves. So this is a research area. This is a key topic for development in 6G, is how to actually model the energy use for a particular service, for a particular user, for a particular network customer, and to be able to identify which characteristics of this are essential, which ones can be reduced, and which ones are excessive, right? Going back to my previous point, where the service providers themselves And here I don't mean the mobile network service providers. I mean the big network service companies themselves. They have to be held accountable to the way they engineer and deploy their services, so that if they require tremendous amounts of communication, then they are going to be identified as being responsible for a certain amount of the operational expense. And that's the only way that services will be developed with service sobriety, where they focus on delivering the service that the people need without just throwing excessive amounts of updates and other as a digital garbage at the problem. Thanks.
Thank you, Eric. Professor Bhaskar, anything you want to expand on top of what you already said at the beginning?
So, good, huh? Yeah. So I think, see, you mentioned about quality of service, right? So in an analogous situation, you might say that being able to get from point A to point B as quickly as possible is better quality of service. But we do give options to people to use a cycle, right? And once we do that, then policymakers are able to intervene and provide cycles for free, and so on, right? So I think the first step in a lot of the things would be in 6G to make everything measurable. So if I'm sitting in a place with a poor link budget, and if I want a high data rate, then somewhere the metrics must show that I'm consuming more energy, and that will first of all enable me to make choices. Maybe I'll spend a little bit more and get an optical fiber connection or something in my home. The second thing is, next step is it enables policymakers to incentivize those who don't do those things, and so on. So I think one of the things we could probably think about in 6G is to provide much more accurate measurements of pretty much every choice, and both from the user and the TSP side. Okay, so if they decide to have less sites, it has an implication, right? So I think that measurement is the first step. If you hide measurements, you're basically trying to make choices for others and then force the issue. Thank you.
Excellent point. I think it also makes users a bit more conscious, and how you, like, whether you want to opt in or opt out of.
Give an example on the AI case, right? I mean, let's say by 2030, as he says, God forbid, we all start using AI enormously and we keep consuming a lot of energy. I think it will matter a lot whether we run the application in the daytime or in the night, because if you run in the daytime, probably the data center is using renewable energy. So if you don't measure some of those things, you can't enable policy, you can't enable choice. If I am a conscious person, I may decide, because the only person who can decide whether I can wait till next sun time is me, not somebody else. Or if I decide not to wait, then some policy could charge me for it. So I think measurement is the key.
Excellent. So maybe I think time-wise, so maybe just since we're talking policy, I want to kind of maybe go to Mr. Avinash. We recently had G20 happen in India, right? And sustainability was, I think, a big part of those discussions. Are there any specific actions that have come out of G20 for either TEC or just for our community as a whole?
Not specifically related to G20, but within Department of Telecommunication, we already are working on an action plan for circular economy for telecom, and we already have some circular economy action plan and policy for the IT side. Similarly, we are working for the telecom side, which has a vision and an action plan. So we are working with the equipment manufacturers, network operators, associations, and NGOs and others. So that is almost in the final position. And also within TEC, we already have published the standard for energy consumption rating ECR and the energy passport EP. So those few initiatives are already there, and definitely like the sustainability part, which has now become part of the IMT 2030 framework. So a lot of contributions had come from India, and somehow TEC was the nodal for that Indian contributions. Thank you.
Vikram?
So on the policy front, what has happened is that the the Environment Ministry has included telecom equipment as a part, as he mentioned, from 2016 onwards, the electronics equipment was already part of the CPCB and the e-waste rules. Recently, telecom equipment has been included. We are having some challenges about, because it is all based on targets. So what they've done is they've given a phased-wise implementation with year 1, year 2, year 3, and the amount of equipment in terms of tonnage that you have imported, and then you do e-waste and e-recovery. So as a part of the sustainability or circular economy applications on telecom. So the policy is out. COI and its members, we are working on how to get our arms around it. So not really related to G20, but in terms of applicability to the telecom sector in India. And that would contribute to circularity.
Excellent. So thanks, Vikram. So I just want to give a chance if audience want to ask any question, maybe one or two. Do you have a mic that can be passed around? Yeah. Please introduce yourself and then the question. Thank you.
I'm Venkat Ramaraju Chelli, Director of Quantum Technology, TEC. Basically, the energy efficient performance, energy consumption, and user friendliness, cost, and all are interrelated. How the policy has to be framed to compensate, because they are not natural forces. Unless there is a policy and regulation, is a very reasonable and systematic implementation and convincible to the as a user, as well as service providers, as business entities, it is not practically possible to implement. Though the TEC also released the document for energy passport, the problem is acceptance and visualization of importance of these standards implementation is to be seen holistically. I think so some remunerative is very much required in the compensation as for the energy saving, because the sustainability is one of the important as a G20 or can be a vision document 6G, or even globally the awareness has increased many folds in sustainability because of temperature increment, global warming. Is the 1 more degrees rises, it's havoc on Earth. Everybody knows that. So this is really required and the energy efficiency, like optical device, which consumes 50% of energy of the other semiconductor device. So each prospect, there is a device prospectus, a consumer, the per unit of bits usage should be incentivized, like insurance, no bonus claim, like when somebody uses a less data rate, they should be incentivized. And there is a tools, if you see the real example, we have the many photos, we duplicate many things, many photos, many places. Not only just one example. So these are many things, real life, as a digital waste, as rightly said Mr. Teotia, hidden energy efficiency where we can do lot in that also. These are the tools which are to be made affordable to the public and to be encouraged to use of it. So it's a very recursive process, I think. So there is certainly the policy and regulation initiative, all is interlinked, and energy passport is which is at TEC release for almost all the latest devices in telecom sector and ICT sector is released. Even globally, they will look at that only the servers are implemented, but in India is just taken care for all devices. Certainly, we should look the positive prospectus, but how to make sustainable and sustainable to implement and acceptable to the all stakeholders. That's my point.
Thank you. So it's more an observation than a question. Final.
My name is Rakesh Mehrotra. I've got just out of box thinking type of thing. Professor Bhaskar referred the cars and all those things. If I look at the car, the global occupancy in a car is 1.2. where the car is made for 6 or 8 persons and so much of tonnage and all those things. Now, similarly, now this has to be thought of what the mode of transportation should be there so that we can reduce the energy consumption on that, wastage of energy. Now, similarly, in the telecom, we have to think of something because what we are giving, what Vikram was saying, the garbage. We are giving a lot of garbage over what's needed over there. For example, I was in broadcasting industry. Instead of giving high definition, this entire thing over there for the 6 months or a year, when they want to, if I take the only one frame per, say, 5 frames per second, per second, I will be in a position to make out the story. So why should we keep all those things? There should be some restrictions on that imposition, right at the design stage itself. So we don't waste the thing. So that particular type of things we can think of in something the telecom industry also to work it out on that. Thanks.
All right. Thank you for the inputs. I hope somebody is making notes. Yeah, we are actually really running out of time, but gentleman in the middle there, last question. Please.
Yeah, thank you.
Yeah,
And
please be brief and maybe a question if you can.
my name is
Right,
Sharad Sadhu from Fraunhofer IIS. What I understand is that when you have a network or an operation, there are so many trade-offs. So we cannot have more data and less energy. Or, for example, in the spectrum area, you cannot have more data throughput and use less spectrum unless you put more power. So to my simple mind, it looks very complex that you keep the same data or put more data and use less power, unless you have some technical innovations or inventions which are a better technology. So that was a part of the comment. What my thinking is that we must look at the consumption side. For example, we must look at limiting the consumption or controlling the consumption, like somebody said, the consumption passport. From the consumption side to reduce the data that required by people. For example, in our country today, data is so cheap that everybody is using data without any botheration. It is just like water in the river. In fact, water in the river is less than the data that flows. So we need to look at the usage patterns to incentivize the people for using less data. That would be one solution of reducing the consumption. Thank you.
Thank you for that. And I think we need to wrap up the panel discussion. So I would like to thank all the panelists for your insights and participation in the discussion. I believe we had a very good debate with touching diverse areas. I think maybe if I were to take away, I think I hope we all agree that sustainability is important, and I think we should all invest in every way we can to kind of, as we start to think in new technologies going into 6G. I think we all need to put our minds together and see how we can address sustainability from a design principle point of view, not as an afterthought. And of course, we talked a lot about trade-off. I think you got some ideas from here in terms of how you want to kind of balance in that trade-off situation. And I think one aspect that Professor Bhaskar mentioned about maybe we should start to actually collect or measure the data, because unless you actually measure, you don't know. You can say all you want, but when you don't know what parts of the system are actually consuming the energy and why, I think we can't do much. So I think having that and policy, of course, without policy, things don't get into action. So maybe there's some work to be done on the policy side. So I think this is all good. And yeah, we have TSDSI. So if you have needs for standardization, we have a platform, of course, TSDSI, and then we have global organizations like 3GPP and ITU. So we welcome your inputs. So thank you very much once again, and I'll hand it over to Bindu.
Thank you very much, Suresh and the panelists, for this very engaging panel discussion. My key takeaway is measure my digital footprint and try to minimize it. That's just one lever. Before we end this session, can we have a group photograph with all the panelists in the room in the front? And if on the digital screen, we can have Eric and Susanna also. Yeah, we can have Eric and Susanna. Yeah. Thank you very much, sirs. We now move to the last